Okay guys, my name is Christopher Parham here at Lipo Connection Solutions, and I'm also known as IceCube57 on the Industry Forum. This is another battery review. Thanks for the donations for the batteries. I've still got a few more to test, and I'm just doing this in my spare time, so just bear with me. But the one that I'm reviewing now is the um, Turnigy Bolt high voltage battery, and this one is a 65C to 130C battery. Um, this one, it was very promising, but in a way it was kind of disappointing. Um, the issues that I had with this battery is about the battery. It was balancing out quite well and everything. The cells stayed pretty close together through most of the discharge, so I didn't have too many issues with that. So I was able to do full discharge, get full capacity out of the battery. But definitely once I started going to the higher discharge rates, um, I started getting cell heating and therefore a little bit of bloating. So the pack is a little squishy, but overall it's still delivering capacity, but is quite significantly bloated. Um, and for the higher, like when I got the pack, it was a nice firm pack. Um, but like I swear, like after maybe I would say maybe about this is a 2200 milliamp hour pack, 2.2 amp hour. So after I started testing it about, I would say maybe 10C, I was noticing significant heating to where I had to put the cell and a vise in between two pieces of wood and clamp it just to make sure I get decent clamping force to make sure, all the cell layers and everything were nice and tight to keep all of my discharge test uniform, because I'm pretty sure if I were to test this battery as it sits, it'll probably bloat even more, and then I would definitely start seeing capacity loss because of the electrolyte gassing in it. Um, let's see, during the discharge test, what I noticed on the curve, especially at the higher discharge rating, let's say like around 20C, which, well, about 20C, which is around 40 amps, 15 to 20C. And I picked this range because the higher ranges, I mean, the discharge was so fast on this cell at 70 amps, which 70 amps on a 2.2 amp hour cell isn't a lot, but again, that's the only way that I can really simulate the high C ratings of packs, is just to use smaller capacity cells. But what I was noticing is on typical lipo, I compared this to a B grade lipo, the black Turnigy lipo that's B grade, and it was like 40C, which was an extremely good pack, in my opinion. I don't know the long term effects of the B grade lipo, but what I tested was damn right outstanding. It was hanging up there with some of the not the nanotechs, but some of the with some of the nanotechs. So it tested out really good, and so since this is a high voltage, high discharge battery, 65 to 130C, I thought I would compare it to a nanotech grade pack. The B grade may seem like it's subpar, but it was actually tested pretty good. But what I was noticing is um, the first part of the discharge from 4.35 down to about 50% of the capacity, it was very, very steep. So it was almost linear to an extent. So it was more like a playground slide or whatever. It was pretty straight down, and then once it got down to about 50%, it started leveling off quite noticeably. So it started out straight, and then it kind of went. It started out kind of vertical, and then it went kind of horizontal for a bit. And of course, this is like most lipochemistries, but the difference between this one and the regular lipochemistry that we know that discharges to 4.2 is the cliff. The discharge cliff at the very beginning on regular lipo is very, very sharp, and then it levels off. So the 4.2 to 4.0 or 3.9, 3.95. It's very, very sharp, and then it levels off. But with this high voltage pack, it was more linear. It wasn't straight vertical down. And so what I also noticed for the first part or first 50% of the discharge is the the high voltage pack held about a 0.2, 0.25 higher voltage at the beginning of the discharge, but after the 50% discharge, it pretty much tracked with a regular LiPo. And at the end of the discharge, it pretty much, like at the knee of the discharge, was quite similar. So, at the very beginning, you're going to get a nice punch and probably about 0.2 volts a cell higher with a high voltage pack versus a regular LiPo. This may benefit some people, but for me, is I'll rather have consistent power for the whole discharge instead of it being so linear. Because like I said, one of the things you're going to notice is you're going to have good power in the beginning, but um, the power of the bike would rapidly decay until it gets about to 50%, and then it'll be kind of mundane and on par like with regular LiPo. Um, at least with a regular LiPo, if you have your battery voltage high enough, you can pretty much predict everything from 80% all the way to 20% is going to be pretty level. With the bolt, it's not going to be so much, so it's just going to be linear to 50% and then level off. So really good performance, then it just kind of gets kind of flat. So you're gonna be like, yeah, yeah, and then it's like, well, fuck, it won't go any faster or whatever, and that's when you hit that level part of the discharge with the bolt. I can't say that, the also the C rating of the pack, it did perform really, really well compared to some of the other high C rate packs. But again, it's kind of really hard to compare. It's like apples and oranges. The pack does have a 0.25, point 0.2 to 0.25 volt advantage at the beginning of the discharge, but at the end it's just performing like a regular LiPo pack. And then, like I said, the other thing that concerned me was the cell heating. Um, and I've had 2.2 amp hour packs perform really, really well and stay solid. And then I've had other packs that bloat like this one. Like I said, this one is really, really squishy. The other 3 amp hour cells that I've tested, 2.2 versus 3 amp hours, not that big of a difference, but every single 3 amp hour cell that I have and the other chemistries have remained brand fucking new. Like, it's, you can't tell that I abuse them, but this one is just um, noticeably bloated on both sides. So actually, when I was discharging this battery, cell 1 and cell 2 were the weaker cells, but cell 3 was the high flyer, but it wasn't that far behind. But here it is. We have a pack, and if I press on this side, it's just as bloated as this side, even though when you look at the discharge graphs, one side should have been performing a lot better and cooler than the other two cells in the pack. So I'm not sure if this is an indicator on what the larger batteries um, would perform like. This was an expensive battery, so I really can't justify. I'd rather have more watt hours in range and more predictable discharge than just to have the advantage of 0.25 volts um, over the first half of the discharge of the pack. Now, what does this translate to? I'm just pulling out my calculator here. So we have 0.25 volts higher voltage on the discharge. So we multiply that times one of the, let's say, 24 cells for you 100-volt people. 0.25 volts times 24 is 6 volts. So, but also the thing is, you got to look at 4110 FETs. Their limit is 100 volts. maybe a slightly higher if you like to ride the edge. So running 24S, 24S with the Turnigy bolt batteries will more likely blow your controller because they'll be at like 100.6 volts and the MOSFETs aren't rated for that voltage. So let's step down to Turnigy, so 0.25 volts times 20. That would be 5 volts extra that you would get. So instead of having an 84 volt pack, you would have an 89 volt pack. So it'll be 89 volts at the top of the discharge. It'll be 89 volts starting, and it will probably drop down to 84 volts. And so with regular LiPo, you'll start at 84 volts and probably drop down to, let's see, 4.0 times 20. So you'll start at 84 volts, and right out the gate, it'll probably sag down to about 79 to 80 volts right after, full charge 4.2. Normally the pack, after you knock that surface charge off, it'll settle around in 4.0 to 3.9, 3.95, so right in that range. So basically, you would use the Turnigy bolt battery to counteract voltage sag, at least for the first half of the discharge, and then for the second half, it'll just perform normally like a regular LiPo pack. So other than that, I really don't have much to say. The C rating is okay, but like I said, at higher C ratings, I did have a lot of cell warming and bloating. But then again, looking at my discharge test, you're talking about someone holding a discharge for a continuous discharge of the pack, which is pretty much not what you do on a bike unless it's like a drag bike or something like that. At the higher, just think this little small pack, I was discharging this in like 2 minutes, 2 to 3 minutes. But like I said, this is a small capacity pack. So even if you scale that up, we're talking about, this is 2 amp hours and me discharging in 2, 3, 4 minutes. That's significant. Normally even the people that are punishing their bikes, we're talking about like 1 amp hour a mile, 1.5 amp hour a mile, and that's pretty aggressive. But even the discharge tests that I'm doing aren't comparable to what you see on the e-bike. Normally the average C rating on the e-bike is 3 to 5 C, sometimes up to 10 C on average when you look at the discharge of the whole pack. So when you look at the discharge rates that I'm doing them up to 30 C continuous. And we have the quarter rule, the quarter C rating rule. So if this, we're taking the lowest number, which is 65 C, so 65 divided by 0.25, we'll multiply it by 0.25, so 65 times 0.25. We're talking about 16C, which is on the upper end of the pack. And so, like I said, past 10C, around 10 to 15C, I was noticing significant heating and bloating out of this supposedly high discharge pack. So if you trying to get a leg up on voltage, you would probably, let's say, get that higher voltage for the first half of the discharge. But whether it would be worth it C rating wise, I really wouldn't consider this a 65C pack. I would kind of consider it 10 to 15C with risk. So other than that, I can't really think of anything too much to say about this. Well, this particular packet has 12 gauge leads, so again, for this to be a 2.2 amp hour cell, and it's saying that it can sustain 65C, so 2.2 times 65 is 143 amps. One of the things I do notice about how Turnigy rates their packs is you can tell a lot by the gauge of wires that they choose. If this was truly a high C rating pack, I would expect possibly 10 gauge on a pack like this, especially if it can deliver 143 amps peak minimum, and doing 2.2 times 130, this equals 286 amps. And again, like, given the silicon rating and everything, I've been a silicon fanboy, and yeah, you can put a lot of abuse through silicon, but peak 286 amps through 12 gauge wire, I'm not even sure why is this even rated this high. I wouldn't even give it this high. I would expect this to perform along the lines of probably about a 30 to 40C pack, not a 60C pack. And then even with the derating of it and everything, so we derate a 40C pack closer to 10C. So that's what I would kind of expect for this chemistry. So yeah, it's but anyway, going back to what I noticed about the discharge, um, I was trying to see if I had another pack. Like I have a graphene pack here. Let me just grab that pack real quick. I have this 65C graphene pack, 3 amp hours, and it has what, 10 gauge leads, you know, and this 2.2 amp hour pack has 12 gauge leads. I understand this is probably meant to go on a much smaller device and everything, but it even goes as far as here's one more pack. Here's a 15C pack. This 15C graphene has 14 gauge leads, and so again, going on the quarter scale, 15 divided by, multiplied times 0.25, is 3.75 C. So 3 times 3.75 would give you 11 amps. So this pack would be 11 amps safe continuous discharge, which falls in lines with the leads. And so I kind of see that kind of leads to more validity of the quarter C rule. So, you know, going back to this bolt 65C, derate that by the quarter C rule. Let's see, 65 times 0.25. 16.25, and multiply that times 2.2, which is the amp hour capacity of the pack, we get 35 amps. So I will consider 12 gauge wire being perfect for 35 amps. Going to the graphene, we got 10 gauge leads, 3 amp hour capacity. So this is a true 65C pack, 0.25. Well, 65 times, I can't remember these numbers, 0.25, 16.25 C, multiply that times 3, equals 48 amps, which, you know, but this one, this 3 amp hour graphene pack, actually, it really performed really well, you know. So yeah, so when you look at the ratings of the pack, make sure you pay attention to what the discharge leads are on Hobby King. They should give the description, and it'll give you a good indicator on what the packs are truly capable of. But in some cases, you know, at least for this one, this seems kind of odd and kind of fishy. It's almost like, oh, we're going to go up on C rating and wire just to kind of support the bolt chemistry and it being high discharge. And let's say, granted, it was able to stand up a little bit, but again, like I said, I have to knock off a few points due to the bloating and everything. But I'm rambling at this point. Like I said, I hope this gives you a good indicator on what the Turnigy bolt line is capable of. It's very, very premium price for the pack. C rating is okay, but you're gonna have to deal with some heat and possible bloating like I did. And And if you want good performance for the first half of the discharge, like if you, let's say if you had like making a 10 or 15 amp hour pack and you're just one of those people that like to rip it, but I wouldn't say you get bored of it very easily, but you find yourself not even discharging past 50%. This is a good way to get peak performance out of the first half of the discharge, and then baby it on the way home, or just go home and charge it back up. It'll be a good pack for that. But like I said, it's going to start out strong, and you're gonna lose power like really quickly, and then the power will level off. The power and performance will level off, and then it'll just, I wouldn't say perform anemic, but that out of the gate feeling that you will get, it will quickly disappear, and then it'll just kind of be flat for the rest of the discharge. But again, Ice Cube 57 on Illustrator Forum, otherwise known as Christopher Parham, owner of Lipo Connection Solutions. Thanks for watching.